Next topic is C preprocessor. The C preprocessor is a separate step in the compilation process. It is a text substitution tool and it instructs the compiler to do the required preprocessing before the actual compilation. So let's see how the flow works. So if you have a file hello.c which displays hello in the output screen, it has included stdio.h header file in that program. So both files hello.c and stdio.h, which is available in the library, both are sent to the preprocessor. The preprocessor takes the code from the stdio.h and include in the C program and makes an expanded source code which is sent to the compiler. Compiler then compiles the code and create the output the object code. This object code is used by the linker and it maps to the memory, and finally the program execution happens. So this preprocessor is happens before the compilation, and all the preprocessor directives starts with a hash symbol. And see, preprocessor directives are used for macro expansion, file inclusion, conditional compilation, and miscellaneous directives. So we'll see how it is used for macros and file inclusion. Next topic is macros. Macro is a named block of C statements or expression which is declared using a preprocessor directive hash define. So when the code is passed through the preprocessor stage, it is examined by the preprocessor for any macro definition. When it sees the hash define directive, it goes through the entire program in search of macro templates. Whenever it finds one, it replaces the macro name with the appropriate macro expansion. Only after this procedure has been completed, the program is handed over to the compiler. So it is a text replacement process. There are two types of macros. One is object-like macros. Second one is function-like macros. So we'll see an example for object-like macros. So in this example, we have defined a macro called pi with a value 3.14. So the directive used is hash define. Inside the program, we are finding the area of the circle. So the radius is given as input and area is calculated as pi into r into r. So we have used the macro name in the program. So what will happen during the compilation and execution? So when this program is passed through the compiler, before it reaching the compiler stage, first it goes to the preprocessor stage. In the preprocessor stage, wherever the pi is written, it get replaced by its value 3.14, and it goes to the compilation and then it get executed. So the identifier pi is replaced by its value. So that's how the macro works. Next one is function like macros. In function like macros, the macro name gets substituted with an expression and it accepts parameters also. So in this example, we have defined a macro area with parameter x, and the expression is 3.14 into x into x. So inside the program we are finding the area, and we have variable r which is of data type float, and it accepts the radius given by the user. Area is assigned to the variable a, and we have specified the macro name area, and inside the bracket we have given r as the argument or the parameter. When the preprocessor sees this statement, it replaces the macro with the expression which is specified using the hash define directive, and then it computes the area of circle. So what is the difference between macros and functions? In a macro call, the preprocessor replaces the macro with its expansion. But in a function call, the control is passed to a function along with the arguments, and the calculations are performed in the function, and the value is returned back to the calling program. So macro replaces with the macro expansion, function makes calls and return the value. If we use a macro 100 times in a program, the macro expansion goes into every place we have the macro name. So it replaces the macro name at different places. But if a function is used, it makes the function, it doesn't make any code change. It doesn't insert any code inside the program. Instead, it make a function call that many number of times. Next preprocessor directive is hash include. Hash include is used to include a file in another file. So this is also a preprocessor directive, and it starts with hash include. We have used this directive in almost all the C programs to include stdio.h header file. So what does it do? It simply inserts the entire content of the file into the source program, and then passes the expanded code to the compiler. So there are two ways to write hash include statement. So you will see a small difference. This is hash include and file name inside angular bracket, and hash include file name inside double quotes. If we write file name inside the angular bracket, it tells the compiler to look for the directory where system header files are maintained. If we write file name inside double quotes, it tells the compiler to look for the file inside the current directory where your program is saved. So what is the use of using hash include? So hash include is used in two different cases. If we have a very large program, the code is maintained can be maintained in different files based on their functionality. Hence, it is easy to maintain the program, as we have sections are maintained in different files instead of a one big program. So now how do we include all these files in the single main program file? We use the hash include. So this way we can achieve modularity. In second scenario, there are some functions which may be required in many programs. For example, we are using printf function. Printf and scanf functions are used in almost all programs that we have written, which is used to display the in the output as well as to accept the input. So these commonly needed functions are stored in a separate file, and this file can be included in the program which we write. So instead of writing these functions again and again, we can include this file inside the program, and all the statements in the file get inserted into the program. So this way we can reuse the existing functions. So these are the two purposes of using file inclusion.